Let's get going with today's class. So what we're going to be doing today is we're going to continue our look at statistics and data analysis. Once again, planning out what we're going to be doing with the data that we are in the process of collecting. So again, important to keep focused on the big picture. And just to remind you, we are just under about a month away from when the abstracts will be due for the URC, and then you have an additional 20 days after you hand in your abstracts to finish up your presentations. So we're going to wait to talk about exactly what you do in your presentation for that part of the semester. We're just going to remind you, this is, again, where you finally get to tell the world about the wonderful work that you're doing. So this was just a couple of years ago when I did the senior seminar, and there's Daniel Newman, and she gave this great presentation on her project, which had to do with the ability of people suffering from post-traumatic disorder to actually recognize positive and negative facial expressions. So this was her at the Undergraduate Research Conference. It's available on my YouTube channel if you want to take a look at some of the work that was done. But again, this is what we're driving for, to be producers of psychology and not just consumers. So once again, on our trip through from having nothing to having a finished project and a published article, we are currently right now working on our results draft. We're preparing, in other words, for our results draft. So while we might not have massive amounts of data to look at right now, especially if you've just started running subjects, or if you're almost there to the point where you can run subjects, we do have the ability now, however, to plan out what we're going to be doing with our data. So it would be a good idea to do that during this time. So what we're going to take a look at today is we're going to take a look at what I like to call my statistics decision tree. And hopefully by using that, we are going to be able to, for most of us here, decide on what statistics test we're going to do, and we'll know by the end of today. And then I'll just mention a one-stop statistics shop for most things, specifically for that one sample t-test, paired samples t-tests, independent samples t-test, one-way ANOVA, and univariate ANOVAs and repeated measures ANOVA. So if your test falls into one of those six, then there's a place where you can access some resources, and I'll talk about that. And if it doesn't, or even if it does, we'll just briefly mention the thing that is going to become your new best friend. All right, so statistics decision tree. So without having collected any data, without having tested a single subject or found a single source of data or looked at a single sample of artifacts, we can still plan out exactly how we're going to run the data that we'll eventually get. And that's what this statistics decision tree is all about. So what we're going to do, and we'll work through, we'll split up into groups and work on this in the second part of today's class. But one of the first things that you need to do is you need to identify and you need to decide what kind of independent variables are you dealing with. And for our purposes here, there's really only two types of independent variables most of the time that you need to think about. The types are whether your independent variable is what's known as discrete or whether it's continuous. So discrete means that you can divide your independent variable into different categories, right? So if you are looking at gender differences, male and female, those are two separate categories. That's a discrete independent variable. If you are looking at college majors, right, psychology, history, mathematics, those are discrete categories. They are separate categories. Continuous variables are exactly what they sound like. Those are variables that are continuous. So if you're looking at something like GPA, right, it's not just high or low GPAs. It's not categories. It's continuous. Maybe you have a 2.63. Maybe you have a 3.14. Maybe you have a 3.95. It's a continuous number. So the first thing you want to decide is for your independent variables, are you measuring them as discrete variables that are in distinct categories, or are they being measured continuously? So if you're doing it discretely, if you have your variables in different categories, and there is no order to your variables, then this decision tree that's coming up is going to be the one that you want to take a look at. So what we mean by no order is that there is no way to put your discrete categories into any sort of meaningful order. So if you were doing a study on anxiety levels at different years in college, and you said, all right, I have one category, those are freshmen. One category, those are sophomores. One category, those are juniors. One category, those are seniors. That's a discrete category, right? You're either in year 1, year 2, year 3, or year 4, but you can easily put those in order, right? You can easily put those in order of increasing time at school. What we're talking about here are discrete independent variables that have no order. And the classic example is male or female. You can't put that in order of increasing gender, right? It makes no sense to say females are more gender than males are, or vice versa. So if you have discrete independent variables that do not have any order to them, what you want to do is access this decision tree and figure out what it is that you're going to do. So the first thing that you want to ask yourself is, how many independent variables do you have? And it really only matters if you have one independent variable or if you have more than one. So the decision is first, how many independent variables do you have? Do you only have one cause that you're looking at? Or do you have multiple causes, multiple independent variables? If you only have the one, next thing to ask is, how many levels of that variable do you have? How many discrete categories do you have? If you only have two, you only got two discrete categories, then you're going to be doing one type of test. You're going to be doing a t-test. If, on the other hand, you have more than two, you're going to be doing an ANOVA. So if you decide that you have two levels, you got one variable and it only has two levels, you are doing a study only on gender differences, and you're only looking at males versus females, that would be one independent variable with two levels. You then have to finally ask yourself, what is your independent variable type? Specifically, is it a between subjects independent measures variable? Is it a within subjects repeated measures? Or is it a single sample that you're comparing to a hypothesized value? So what is your independent variable? Between subjects, that is a variable where you have split your subjects into two separate groups. So you've split them into high achievers versus low achievers. You've split them, well, that has order. Yeah. You've split them into males versus females. You've split them into liberals versus conservatives. You've split them into two groups, and they don't get to be in both of the categories. They can only be in one. That's a between subjects independent measure, and then you are doing an independent samples t-test. So if you follow this tree down this path, and this is where you end up with, that is the test you are going to run. You're going to be doing an independent samples t-test when you finally analyze your data. If, on the other hand, the independent variable type is a within subjects repeated measures, and what that means is that subjects go through both categories. So if you have them trying to remember words, and then they're also trying to remember pictures, right? That's an example of a within subjects repeated measures, where the subjects get measured repeatedly across the two conditions. And if you do that, then you end up with a paired samples t-test, also known as a repeated measures t-test. And then finally, and this is probably going to be a little bit more rare, if you have a single sample that you're comparing to a hypothesized value. So maybe you have found some data that says this is how anxious an average student is for their, for college exams, and this is what I measured my sample to be, their level of anxiousness. If that's the case, and I don't think anybody in here falls in there, but just for completeness, if that was the case, then you would do a one sample t-test. That would be your final decision. All right, so that is if you are doing one independent variable and it has only two levels. If you're doing one independent variable, you only have that one cause that you're looking at in your study, and you have more than two levels, right? So in this case, you are looking at anxiety levels throughout the, well, that's also a bad example. You're looking at majors, and you're looking at history majors, and psychology majors, and mathematics majors. You're looking at three levels of majors. Specifically, you have more than two. Well, in that case, again, you have to ask, what is your independent variable type? And if your independent variables are between subjects, independent measures, where each subject only participates in one category. So you're either a history major, or you're a psychology major, or you're a mathematics major. You're not going to have people in all three categories. If that's the case, then you are doing a one-way, what's known as a one-way ANOVA, a one-way independent means ANOVA. If, on the other hand, your independent variable type is within subjects, repeated measures, where somebody can participate in all three categories. So you have them remembering words, then they're remembering pictures, then they're remembering colors, then they're remembering smells, right? But they're in all four categories. If that's the case, then you do a within subjects repeated measures, and you end up with a repeated measures ANOVA, and that is your final decision. Mm-hmm.
So for mine, I'm administering surveys that already establish scales and trying to find a correlation between them. So I'm not going to be doing any of this.
None of this so far, because if you're looking at correlations between surveys, typically you're on a continuous variable.
Okay.
So the line between continuous and discontinuous is not as hard and fast as some people would like to think. So if the scores on your survey can go anywhere from 0 to 30, that's pretty much continuous, right? If they can go anywhere from 0 to 20, that's pretty much continuous. If they can score anywhere between 0 to 10, I would consider that continuous. If, on the other hand, you can only score 0, 1, 2, 3, 4, or 5, that's when it starts to get, well, maybe these are, treated discrete. But yeah, for you, you're dealing with continuous variables. So you're actually nowhere on this so far. We'll get to yours. All right. So this is if you have the only the one independent variable. Now let's take a look at what happens if you have more than one. So we'll get rid of those. If you have more than one independent variable, if you're looking at the effect of two things on a specific outcome, then what you want to do is, again, ask yourself, do you have a within subjects variable? If you have one within subjects variable, it's going to be different than if you have no within subjects variables. But this is the one that counts. Do you have at least one of these? If you do, then what you're going to do is you're going to run a repeated measures ANOVA. And technically, it's called a mixed ANOVA because you're mixing within subjects, and you might be mixing within subjects and between subjects. The reason I put it here is because SPSS uses this to run both of those scenarios. So if it's all within, then you run your repeated measures ANOVA. If only one of them is within, then you run a repeated measures ANOVA. Basically, if you have at least one within subjects, one variable where the subjects encounter every condition on that variable, you're going to be doing a repeated measures ANOVA in SPSS. If you have more than one independent variable and none of them are within subjects, meaning that for each of those variables, subjects only experience one category, one combination of your variables, well, that would mean that all your independent variables are between subjects, and you're going to end up doing what's called a univariate ANOVA. Specifically, you're going to end up looking for that in SPSS and running this and testing all independent means variables. All right, so that is the decision tree. Once again, if you have discrete independent variables and there is no order to those. All right, next one. So here we have the situation for you. Continuous independent variables with order. So a continuous independent variable, it almost goes without saying that it's with order, right? You can't have a continuum without being able to order people on that continuum. So if you have a continuous independent variable, you are doing this with order. And one of the nice things about being able to order your variable levels, your variable scores, is that statistics can take into account that order when it's analyzing the differences. So in an ANOVA, it doesn't take into account that order, and it just compares categories to each other. What you want to do in this case, though, is you want to use something that can actually take into account and use that order in its analysis. So for this one, once again, same basic idea. Ask yourself, how many independent variables do I have? Do I have only one independent variable? One variable that is trying to predict the outcome? Or do I have more than one? So again, either you have one or you have more than one. That's going to determine your test. And then how many levels do you have? Well, for this one, it's continuous. You got more than two. Right? That is literally, you have to have more than two. Otherwise, you don't have a continuous variable. It's discrete. It's either this or this. You have to have more than two, so you're on that continuum. And then finally, what is your independent variable? Is it a between subjects independent measure in the sense that you measure people multiple times and everybody goes into the same, everybody's being compared against each other basically? Or is it a within subjects repeated measure? So if it's a between subjects where, everybody's only measured once in the category, then you are doing a simple linear regression. So the simple linear regression, that's what you'll be looking for. That's where you are trying to apply a simple linear straight line equation linking one of your variables, your independent variable, to your dependent variable. Within subjects repeated measures for a regression like this can get very weird, very fast, and usually this is not seen. But if you do have it, it's called what you need to run is a general linear models repeated measures. If you end up down here, I would highly suggest come see me and we'll watch some YouTube videos and hit some Wikipedia pages, together and try to figure it out. But for most of you in this scenario, you're going to end up here in that simple linear regression. All right, so that's for one variable. If you got more than one, then once again, ask yourself, do you have a within subjects or do you not have a within subjects? If you do, once again, that general linear model, repeated measures, regression. If you do not, meaning that all your variables are independent, between subjects variables, independent variables are between subjects, then in this case, you're going to do not a simple linear regression, but you're going to do a multiple linear regression. You're going to try to get two or more variables and figure out a function that predicts that final dependent variable. All right. And then finally, we have discrete independent variables with order. So these are the discrete independent variables where you can actually apply an order to them. So years in college is one of those where you're either a first year, second year, third year, fourth year, but that definitely has an order. Well, in that case, you can, and I'll just kind of go through this a little bit quicker than last time, you can do a regression. So regressions can also be done with discrete variables. There we go. It can also be done with discrete variables as long as they have an order. That is basically the requirement for you to use a regression. It has to have some sort of order. That doesn't mean that you cannot do, if your variables have order to them, you cannot use an ANOVA. But as soon as your variables have order, you can use a statistics test that takes that into account, and then that's one of the reasons why you might want to use a regression. All right, and once again, if you got more than one, do you have that within subjects? If you do, general linear models, repeated measures. If not, then you're doing a multiple linear regression where you can put in those multiple independent variables to predict your dependent variable. All right, so hopefully, and from what I've been reading, most of you will fall into one of those categories. If none of those categories actually fit, so if you're going through all of those decision trees and none of those actually fit the data that you've been looking at, then just come and see me and we'll figure out what bizarro statistical analysis you would need to do. But this should cover, I'm hoping, about 95, 96, 97% of cases. So I'm hoping everybody will probably be somewhere on those. But you never know. I know that when I started doing, corpus analyses in picture perception, I, throughout my entire career, had never even heard of a Poisson distribution and a Poisson test for randomness until I realized that I was nowhere on any of these categories. So I spent some time on Wikipedia, I spent some time on Google, and I found out that the Poisson distribution was right for me for this particular question in this particular experiment, or this particular research. So if that's the case, that's just the case. Don't try to force your study into one of these categories if it doesn't fit. If that's the case and it doesn't fit in any of those, come see me and we'll figure out what to do. All right, so we're going to work today. I actually have those decision trees here printed out. In just a little bit, we're going to split up into groups. And together in groups, we're going to try to make sure that everybody is kind of decided on where in this decision tree they're going to end up. What is the test that they need to do? Or if you can't find it, at least you know that you fall into that category right there. So that's what we're going to be doing in just a moment. But before we get there, a few more things. The one-stop statistics shop. So just so that you know this, one of the greatest things, most helpful things in terms of doing psychology that you can use the internet for is to find resources to show you how to analyze your data. So it is so kind of wonderfully awesome that you can put in descriptions of what you're trying to test. And it'll take a little bit of work, but you can find the statistical tests that you need to use. Now, just to make this a little bit easier, though, I did put together these files, these one-stop statistics shop PowerPoints that take you through how to do these in SPSS, right? So SPSS is the program that you have access here. As a IUSB student, it is installed on most of the computers here in the Psych Lab and in YCamp Hall. You also have access to it for free using IU Anywhere. So typically we'll be using SPSS. If you're at home, as long as you got an internet connection, you can access SPSS through IU Anywhere. So just bear that in mind as we start working, getting closer to actually running the data. But just so that you know, these PowerPoint files here, I made them available. They're in the statistics resources in that one-stop statistics shop. So if you do decide, oh yeah, the repeated measures ANOVA, that's the one that I got to run, you can click on that file. It'll take you through a step-by-step screenshot, basically tutorial on how to do that. And the last thing we're going to do before we break up into groups today, I've already mentioned your new best friend. I'll just let you know about it one more time. Do not underestimate the ability of YouTube to help you out when you're analyzing your data. So I don't know how many times since I have graduated from, with my PhD, did I come across a statistics test that either was brand new to me or maybe I just haven't done it in a while. So I haven't done regressions in ages. My data is usually not ordered in any way. There's no way to order literal and metaphorical. One is not more something than the other. So I don't typically use regressions. But if I did need to run a regression, you better believe this is going to be my first stop. So if you type in the type of test that you want to do, and you type in SPSS, SPSS is wonderful in the fact that it is one of the most widely used statistical packages. So you will have no end of tutorials that will take you step by step and show you how to run your data. And they will show you how to set up your data. Where do you go? What, how do you transfer it to different areas so that you can run it in SPSS? So do not underestimate the use of YouTube for this. It helps out the professionals. There's no reason why it shouldn't help you out either. So, if your YouTube history is filled with nothing but cat videos, now's the time to fill it with some SPSS videos, and just don't overlook it as a resource. All right, so what we're going to do now is we're going to split up into groups. So before I do that, we'll just start passing these out. So these are handouts for the decision trees. On one side, they got the situation. On the other side, they got the tree. So if you can grab one of those and pass out the rest. Question?
Yeah, I think there's SPSS, there's 24, and now there's 25, I think is available on IU Anywhere. We went through a stats class with 24, I think. Mm-hmm. Is there any certain one we have used?
No. SPSS 24 and 25. There will be some minor changes, and usually it's in terms of like the user interface. But, and it might be a little bit more user-friendly. I've gone through a few versions of SPSS. They update it. It's kind of like Madden's football. It's kind of updated every single year. But I've very rarely ever seen anything but cosmetic differences. And stats is stats. It really hasn't changed in the last, 20 years in terms of some of the tests that we're doing. So yeah, if you have access to 24 or 25, either one of those should be fine. All right, so let's split up into group work right now. So I'm just going to pause this.